Well, Mr. Safford didn't bring it, or... Okay. Be careful what you say.
Anything you say can and will be used against you in the court of law. Alright, let's start with this guy. Which was change in velocity over change in time, correct?
Yes.
Yes.
So VF minus VI over change in time. Okay, let's take this and just solve for different variables so that we have a different variable that we have an equation for.
Oh, so just
Just manipulate it, yeah. Okay, so let's solve for VF. And then there you got an equation to put in the note card. Alright, solve for VF. What do we do?
multiply by t.
And then finish by what?
Initial.
Manipulation.
Alright, put that in your note card.
I like this.
I mean, but like, that way we have to solve.
Yes, but this was an easy derivation.
So if you could also give us this one, and then we can find all the other ones too. Wow. Is it math amazing?
Eventually, the last one we're gonna do, we're actually gonna substitute one equation into another equation, and so that's where it will be more beneficial or more helpful.
Time saving. It's nice having set rules for everything. Exceptions.
Alright. You don't have to write the derivations, guys. You don't really need to follow along with your notes with how I did. In fact, I don't even know if you even have a spot to do it.
I mean, as of right now.
No, you can write the equation in your notes. I'm saying you don't have to do like the math and get to it. Alright, so now we're going to take.
Kramer,
Yes?
is that plus A times T?
Yep.
Changed.
You know what?
How is calculating?
You know 70.
Okay. Well, what if we have a particular thing where we want to solve for change in x, but they didn't give us the final velocity?
You have change minus initial.
You could take this and substitute it in to eliminate the VF, and you would have another equation.
Oh
Wait.
So, change in x equals 1/2 VI plus V. Don't. This is not the final. This is not the final equation. I'm just doing the math. VI plus VI. Everyone see what I'm doing here?
Yeah.
So we have to put another parenthesis. But we would have to have the acceleration.
You gonna do something wrong? I mean, I could go like this. Is that what you're saying? That's what I substituted in. Everyone see it?
Yeah.
I took this and I substituted it in, so I'm removing VF because there will be problems where you're asked to find the displacement and you don't have a final velocity. Okay? So here's the general rule. I am making it a little bit easier on you. I know that the teacher our student taught, he was an amazing teacher, he actually didn't give them many equations. So essentially, if you have two unknown variables, you need at least two equations to solve it, because you have to eliminate one of your unknowns via substitution. Does that make sense? So let's just say like a problem like this would be I don't know what this is, and I don't know what this is, but I want to solve for this. That means I got to get rid of the VF, right? So you need to have as many equations as you have unknowns. If it becomes, the more unknowns you have, the more difficult it becomes because you have to substitute a couple times if you need to. Okay, now let's just make this simpler. Yeah, this is not what I want you to put in your note card.
So what if they don't give you acceleration? Because once
Well, then I want to have to use something like that. Yeah. This is just if you don't have
first
to.
formula.
Yeah, Okay, so Now I'm essentially combining the VI's and distributing the change in Tn.
Is that what we're writing?
No? We'll make it even simpler for you.
Oh, you can get rid of the, oh wait, no.
You can get it done.
You can get rid of. You can get rid of the 1/2 here.
No, I put 0.5 on. So we
Plus 1/2 a change in T squared.
You forgot the T.
Yep.
So if you're in Daryl's class, that's good, John.
Yeah, I'll get you a Smarty.
What does this mean?
Smarty.
Wait,
You
what?
corrected
Can you
one of
correct
us,
him?
you corrected, you get $8. I got something, Joe.
Nice.
We get free option.
Minus, excuse me, minus put you 2 up.
No, I already have this down.
You actually made it.
Okay, so I don't know if I stated this the other day, this equation can only be used under constant acceleration.
That's a plus 1/2 acceleration change in T squared, right?
No.
That's supposed to be
Which
plus.
variable do you square?
The rest of that is, but.
Just the T.
Just T.
If I had parentheses with the
Yeah.
squared outside, it would be everything.
Okay, so just T.
Yep. Okay, so this equation is if you have constant acceleration, you don't need acceleration in there if it's constant, right? This one is if your acceleration is not constant. Well, I shouldn't say that, I don't know if that's the case. Well, it depends, it depends on the situation. We won't get into that. Alright, let's do a problem.
Let's do it.
I do that, I want to do that. Okay. Alright. Do you need to walk through this, or do you want to try it and then walk through it?
I want to
Okay,
try it.
try it.
Are we going to use this though? Gave us?
I'll let you decide.
Kramer!
We just decided to walk through it on our own.
No, you guys decided that.
Jeff,
Everyone should go.
Hey, let's try to get through this day and not waste time.
Shouldn't that be velocity?
Yeah, that should be velocity, not speed.
Is velocity and speed the same thing?
No, but they use speed wrong in this case, so it's velocity. Yes. You know the difference between speed and velocity, right? Velocity has to have a direction.
Oh, yes, yes. Yeah, I know that.
So I think you need 2 answers for this question. And I don't think you need the one answer to solve for the other. Because I gave you multiple equations. Had I not, you would have needed to find the one before you could find the other. But we don't have to do it. Oh. Almost positive. Yeah, you can solve for your change in x without your VF.
Alright, sure.
I mean, if you use the other equation.
I need to use that one.
You just said the
What's
equation.
Is that
Next step.
fine? I was gonna say, I'm gonna do
Displacement.
So it's not that equation.
Oh, I just missed it.
What equation?
So like, if it's asking how long the runway is, is the distance?
Yeah. This is how long the runway is versus how long does it take to go down the runway. Yeah.
So technically it's asking for a distance with the equation that's displacement.
Well, yeah, I suppose that's why you try to use it.
So when you're doing, what's the speed of takeoff, you're not putting 540 meters in as the distance.
You solve for the second one first?
Well, I don't know, but he said they're indirect, or they're not directly.
Yeah,
Like,
you
solve for.
can do it a more complicated way, but there are two different equations that you can use separate from each other to solve.
I got it, this one.
You can use the big ones.
So this one that you gave us?
I know.
However, sometimes you can't use a different equation because of one might be specifically constant acceleration and one might be.
You said one was.
The change in x would be first one. Yep, because there's no acceleration.
It was what? Yeah. And then
You can't write that in.
acceleration is 4.2, 4.8, my bad. And then,
Oh, yeah.
change to 15.
Wait, final?
Final is the one you want.
Wait, why would you use this equation to find my distance?
You want. Which one are you trying to solve for? I'm trying to solve for speed or distance. For distance, you use either that one, or you use that one.
Oh, I thought you said that.
You have to use this.
I believe I'm correct, I could be completely wrong.
I highly doubt it.
It's two different ones. There's the initial one.
So you have to find the final velocity and the initial velocity for this. Because, well, I was using the accelerated average equals change in velocity.
Well, you know the initial velocity.
I got the same thing.
That was, oh, true.
The plane is starting at.
Oh, these are
Yeah.
tables.
So then we know
Like
the
new equations.
velocity.
So
Our
start
today
the
is
the
two
initial
examples.
velocity is
Zero.
4.8 meters per second. I guess I should use that.
How'd you get the second one?
Second one, I used the original displacement equation.
So guys,
You don't have to use that.
it appears that I'm hearing some of you are unsure which equation to use. That's part of a really important skill to use for being successful in physics. The best way to do this is if you label all your variables, look at which equation has all the variables but the unknown you want.
But to solve the second one, it gives you something that you don't need to solve.
Well, then don't use the thing you don't need.
No, but how do you know which one to use? How do I
Well-
know that I don't need that to solve the problem?
Look at if you have an equation where you have all the variables, but the one you want and you have more variables than you need, you don't use the one that doesn't go in that particular equation. Like for example, if I'm going to use this equation, and I want to solve for that. Like this is my unknown, Cheyenne. And they gave me acceleration, who cares? I have the other stuff, that's all that matters.
You're throwing so much stuff that we don't need, like, we're gonna try one.
Because how
That's the best kind of.
Okay,
What? What? You don't know what you're doing?
I don't know if I'm ready.
Okay, let me just give you the answers, and then if there are any questions, we'll go over it. What's the final velocity?
72 meters per second.
72 meters per second. And since it really didn't give us much of a direction, I would have just said down the runway. Sometimes if they don't give you a direction, you got to go with the context of the problem. Okay? And then you're changing x, 540 meters.
I got double that for some reason.
By 1/2.
Did you forget the half?
Probably. I just used the wrong equation actually.
So since this is under constant uniform acceleration, where we're using the average velocity essentially, you
Right here. See, I used the equation first. As, that's what I was going for, so I
You mean this?
Distance doesn't have direction. So the answer was that was your change of
That was my
velocity.
change of velocity. And so I assumed that would be
Well, this change in B isn't necessarily, I don't know if you could assume that's your average velocity, which if it was, you would have to divide by 2 because you had an initial and a final, right? Which is why you would essentially have it double. That's why the equation that it has a half in it is because you usually have an initial and a final. If you take the average of 2 numbers, you divide by 2, right? And that's where that half comes in.
okay. So what should I have done?
Okay, so you have this equation that you could have used to solve for the final velocity. Okay, so if you would have labeled everything down the side, you would have noticed, oh, I have an acceleration, I have a time, and I know my initial velocity is 0.
Yeah.
So yes, labeling is huge. You should not start a problem unless you have identified all the variables and written it down the side.
I did do that. I just
Didn't realize that VI was 0.
correct.
Okay? So then figure out there's always multiple ways to do it, but there's always an easiest. Okay? So and that's just due to the fact that I'm giving you a whole bunch of equations that if I just gave you 2, you could still solve it, but I'm making it a little bit easier for you. Okay, when you do that, you should get your 72, whatever this times this is.
Yeah.
Okay? And then the equation that I used was your change in x, 1/2 times VI plus VF times change in t.
So could I? So the first equation that I used was not that equation, but I still got the same answer.
If you would have divided by 2.
Well, I still got 72 meters per second for the first answer.
Well, that's because your initial was 0.
Yeah. So that, but I should.
I'm not sure, yeah, I'm not sure if that was just a lucky situation or if it would work.
Okay.
Again, I am used to just using the simplified versions.
Yeah. Well, yeah.
I'm assuming you could do it the longer way, but I don't want to, definitely say that.
Okay.
Is there another equation you can use?
Yes.
Okay, I'm sad. There's no way we can do this last time.
Yeah, yes.
I used the equation that you just gave us with the change in x equals and then like all that.
Yeah.
And I used that first instead of finding the VF. And it gave me the VF instead of the change in x.
It gave you what?
Like,
You've done that first.
I used it first.
What do you say? Like,
15 times 15 is not 30. That's squared. That is weird. Yeah. So it should be squared. Yeah, that's really ironic, or not ironic, really interesting. I don't know if that's the case always. All right. I'm gonna derive one more, and then we got one more problem. This derivation is much more complicated. Love this.
I'm mad I couldn't figure it out.
No, it doesn't.
no, like,
College
it actually goes, it feels like it's 10 minutes.
I like that. That's good.
Yeah, because I'm learning so much.
Wait, class
Well,
over
no,
in
like-
8 minutes?
I'm just stuck.
Yeah.
Well,
Oh, I
I,
just testify so fast.
This was the obvious, oh my gosh, the other ones I was suffering. I'm sorry.
Sorry.
I didn't understand.
Okay, well, we don't have time to waste any more time. It's going by super fast. Okay, so so far everything that we've done is required time. We're going to give you an equation that substitutes out time.
that's true.
Okay? So I'm going to essentially take this and solve for change in t, which is what I did for that homework problem that you had when I was showing you the number 4 or whatever. Okay, so remember, divide by half is the same as multiplying by 2, yeah?
Yeah.
Divide by change in t. Okay, then I'm also then going to, or sorry, I want to solve for t, don't I?
Oh, that's what it is.
Yep, because I want to substitute, I want to get rid of the t. Does that make sense? So I'm going to solve for it and substitute it in. So I'm going to divide by vi plus vf.
Can we write that down?
Sure, you could write that down. That's an equation that you could write down.
Well, I didn't know if that was the final form.
Okay, and I'm going to take that and plug it into this
Are you
guy.
writing that down?
You can.
You didn't keep the math down
Next
too.
problem.
Not that one. The final product here is what you'll need.
Oh,
But you can write
Couldn't
it.
you use that?
You can
You
also.
could use this. Yeah, you could write this in. I don't know how much you should write that.
Every equation also works in my number.
Okay, so now I'm going to take this t and substitute it in for this t, so I'll have an equation that doesn't have time in it, because I guarantee you will. Do you see? You're going to see how this is going to save you a lot of time.
yes.
This one's a much more.
You're funny.
Okay.
And I just.
And again, you don't have to follow along every little last thing.
So,
No, no.
Why is it separate?
Well, I guess we'll find out if I did it right.
Oh, that's true.
I brought the VI over. Okay, this is going to get confusing. Now I'm going to, what do you solve?
You change what?
I'm solving for VF.
Is that that?
We had two VFs.
That's
So add, Chris.
Okay, I'm trying to remember how I wanted to do this. Okay, so what I'm going to do is I'm going to multiply by VI plus VF to both sides to get rid of it here. So I'm going to multiply by VI plus VF. See how that's going to get rid of that?
Yes.
I'm going to multiply it over here. Eventually I got VI,
Oh, this one.
And you foil it.
yes, and then you foil it. Yeah.
Creamer.
I'm getting.
This
I know.
would
I know, I'm just trying to show you that I'm simplifying a lot of your math.
I was just telling that to
Just like that.
Because if you wanted to do this, yeah, you have to do all of this on your own.
This is fun.
Wow.
That's why
You have to plug in the polygon elements
I
and.
think it's that then, for sure. Okay, when you do that, you really just get VF squared minus VI squared when you foil it. I'm pretty sure. Equals 2a change in x.
Yeah, you're right, you're right.
Okay, and then to finish, it's just this.
That was a smart person.
There's your equation. So here it is, a velocity equation when you aren't given what?
The speed force equation.
The time.
So you could also put a square root on.
Yeah, well.